The Life and Career of Isaac Newton, Genius of Gravity Discovery. Chapter 1, Childhood and Early Years, 1643 to 1661. Isaac Newton was born on December 25, 1642, January 4, 1643, Gregorian calendar, in Woolsthorpe, Lincolnshire, England, to a farming family. Premature and frail, he never knew his father, who died before his birth, leaving his mother, Hannah Ayscough, to raise him alone. At 3, his mother remarried a wealthy clergyman, leaving Newton in the care of his grandmother. This separation fostered a lonely childhood, shaping his introverted, solitary, and occasionally irritable personality, a trait that would deeply influence his later relationships. From an early age, Newton displayed remarkable intelligence, crafting mechanical toys and devouring books. Yet, he struggled at the village school, largely due to a lack of guidance. In 1653, after his stepfather's death, his mother brought him home, intending for him to farm, but Newton showed no interest. A teacher's intervention secured his admission to King's School in Grantham, where his aptitude for mathematics and science began to shine. In 1661, Newton gained entry to Trinity College, University of Cambridge, marking a pivotal moment in his life. He worked as a servant student to cover expenses, while immersing himself in the works of Galileo, Descartes, and Kepler. Though the curriculum focused on Aristotelian philosophy, Newton taught himself, captivated by modern science, laying the groundwork for his future groundbreaking discoveries. University life was challenging for Newton. He had few friends, often isolated, his reclusive nature making social integration difficult. Yet, this solitude nurtured his creative mind, allowing him to focus on his studies. Cambridge became the starting point of Newton's scientific journey, heralding a new era for humanity, though he received no honors or awards during this early phase. Chapter 2, Miraculous Years and Major Discoveries, 1665 to 1667. In 1665, shortly after earning his bachelor's degree at Cambridge, the plague forced the university to close. Newton returned to Woolsthorpe, isolating for 2 years, a period later dubbed the Annus Mirabilis, miraculous years. In the quiet countryside, he laid the foundation for discoveries that would transform the world, though no awards or honors marked this phase. During this time, Newton developed calculus, a revolutionary mathematical tool, later becoming foundational to many scientific fields, despite his eventual priority dispute with Leibniz. He also explored optics, using a prism to split white light into a spectrum, proving light comprises various colors, a breakthrough in physics. The legendary tale of the falling apple, though partly apocryphal, inspired Newton to ponder gravity. He formulated the law of universal gravitation, stating that all objects in the universe attract each other with a force inversely proportional to the square of their distance. Though not fully refined, this idea became one of his greatest achievements, setting the stage for later works. Newton also developed his 3 laws of motion, which would form the core of classical mechanics. These Woolsthorpe years, far from mere isolation, were a pinnacle of creativity, transforming Newton into a towering intellect, though he kept these discoveries private, earning no recognition or awards at this stage. Chapter 3, Academic Career and Controversies, 1667 to 1687. In 1667, Newton returned to Cambridge post-plague, appointed a Fellow at Trinity College. In 1669, he became the Lucasian Professor of Mathematics, a prestigious role, though he disliked teaching and had few students. Here, he published his findings on optics, but faced opposition from Robert Hooke, who criticized his light theory. Newton's irritable, unyielding nature led him to withdraw, avoiding publication to evade criticism. These disputes isolated Newton further, but in 1684, astronomer Edmund Halley urged him to systematize his gravity research. The result was Mathematical Principles of Natural Philosophy, Philosophiae Naturalis Principia Mathematica, published in 1687, a masterpiece that reshaped science. In Principia, Newton outlined his 3 laws of motion and the law of universal gravitation, explaining planetary motion, comet orbits, and tides. This work brought Newton global fame, considered the greatest scientific achievement in history, laying the foundation for classical mechanics and modern physics. He was elected a Fellow of the Royal Society in 1672, a significant honor, following his optics research. Yet, his introverted, easily offended personality fueled fierce conflicts with Hooke and Leibniz. Hooke claimed prior discovery of gravity, while Leibniz disputed calculus priority. These debates deepened Newton's reclusiveness, but solidified his status as an irreplaceable genius. Principia became an enduring scientific legacy, ushering in a new era of scientific inquiry and enlightenment. Chapter 4, Final Years and Lasting Legacy, 1687 to 1727. After Principia, Newton shifted to other roles. In 1696, he left Cambridge to become Warden of the Royal Mint, rising to Master in 1699. He reformed England's currency through the Great Recoinage, replacing worn coins with new ones, pursuing counterfeiters with ruthless rigor, stabilizing the economy. In 1703, he was elected President of the Royal Society, a post he held until his death, promoting experimental research and elevating the society into a leading scientific hub. In 1705, Queen and knighted Newton at Trinity College, Cambridge, making him Sir Isaac Newton, one of the first scientists to receive this honor, recognizing his contributions to science and the nation. He also earned acclaim from European scientific academies, cementing his global influence, though modern-style awards were absent in his era. Newton was passionate about theology and alchemy, studying the Bible, decoding prophecies, and rejecting the Trinity, a heretical view he kept private to avoid backlash. He sought the philosopher's stone, through alchemy, conducting chemical experiments and writing extensively, indirectly enhancing his experimental skills for science. His solitary, irritable nature left him unmarried, friendless, and often at odds with peers, yet it fueled his intense focus on research. Newton died on March 20, 1727, in London at 84, buried at Westminster Abbey, a rare honor. He left a monumental legacy. Principia and Optics, 1704, became cornerstones of physics and optics. From a lonely child to a scientific icon, Newton's life of perseverance and passion offers a timeless lesson in the pursuit of knowledge.